Okay, thank you everyone for joining us from wherever you are in the world. Good morning, good afternoon, good evening. You're in for a very interesting hour because we have with us Andrey Pokhilko, who I've known for many years, and I can tell you it's going to be very interesting. Andrey is the co-founder and chief scientist at Up9, the microservices testing platform for cloud-native systems. He's also a prominent thought leader and an innovator in the open source community. He was previously the chief scientist at Blazemeter, and also the open source initiatives leader at CA Technologies after it had acquired the Blazemeter startup. He developed open source Torahs, he founded JMeter plugins, he created tools that enhance the JMeter protocol coverage and analytical reporting capabilities. And before Blazemeter, he even founded Load Sophia and led the load testing team for 5 years at Yandex. So we're here to learn about microservices mocking with Mockintosh tool, which is an open source tool which was developed by Andrey. And before we start, I just want to take you through some housekeeping. So Andrey, if you could just please take us to the next slide. Great. So after the webinar, you'll get the recording link in your inbox. We have a Q&A session in the end, but there's a chat at the bottom, and there's also a Q&A button. You can use them to ask any questions that you want during the entire webinar, and we'll ask them in the end. And after the webinar, we'll be sending out a survey. We'd really appreciate you filling it out. It'll help us create better content for you to enjoy and consume. And with that, I'm gonna give it over to Andrey.
All right, hello everyone. Welcome to this webinar. And first of all, I would like to make small correction. It's not me only participating in Mockintosh project. It's also a lot of great work from other contributors, and namely main developer of Mockintosh. His name is Mehmet, and I want to give him a lot of credit for all of his efforts while implementing this new open source tool and project. So today we will be speaking about microservice and API mocking. We will understand what's the motivation behind it. We will see the demo of this new Mockintosh tool, how to use it for some basic things. What is its management UI? Why is it so convenient to use it? We will see how to use it in automated tests, and in conclusion, we will summarize the things, we'll answer some questions. As always, I like to have less slides and more live demos. So in the beginning, we will see more slides. In the continuation, we will have more live demo things. So let's understand the landscape and the motivation why we have this problem of microservice mocking, why we use this as practice. And in today's world, we have cloud native reality around us, and it leads to several important changes in the industry and high-tech landscape. First of all, we have increased service fragmentation, where we had one service, one monolith code base, single point to maintain and develop. Now we have a lot of services in different technologies. We have many teams and many technologies used in single application, which makes it problematic to communicate. It makes problematic to understand the technology and architecture of the neighbor microservice. And also we have larger scale of applications today with a lot of data, and it impacts a lot how we deploy the environments for testing and development of those applications. And even if we rely on cloud to provide the environments and infrastructure, cloud costs become real because of the scale of the applications. You cannot just multiply for each developer the fully blown environment of realistic application. The costs getting painful. So this all gets to the situation when getting dedicated environment is problematic for development and testing. And because of this problem, we look towards API mocking. API mocking is a well-known approach and technology. Mock is simply a replacement for the real service. And that replacement is simpler than the real service. It's lightweight and it's controllable. So instead of relying on the real service, we rely on mock. And because it's small, simple, lightweight, we can have mocks and feed the mock into cheap environment. And because it is controllable, we can get desired behavior without complexity of the real service. So mock is simple and controllable, so we get whatever we want, and we'll see today with practical examples how we do it. The main use case for mocks is dependency isolation. It's when you have the client depending on some application which has multiple tiers and you have multiple services, and you want to abstract from that, from those dependencies, and instead you want to rely on mock. And mock, you can now forget about first-tier development dependencies and second-tier dependencies. For example, you can think of second-tier dependency as a couple terabytes of database. And now with the mock, you don't need to use, and you don't need to copy that gigabytes or terabytes of data into your environment. You can just use mock instead. Another use case is predictability. Because you can control the mock, it becomes really convenient to do the front-end development using the mock. So instead of real API, you will use the mock to simulate your desired responses. And we will see today how it actually reflects in the browser when you use it, and that you can now do a lot of experimentation that was difficult with the real service. And finally, there is aspect of lightweight environments, which gives you isolation. All of these smiling developers, instead of relying on the single environment for their development and testing, conflicting with each other, asking each other to not step on each other's shoes, instead they can enjoy individual environments. Obviously, when you use mock, you would still need at some moment to have final integration test when everything is realistic, but it is much cheaper on the earlier stages to use mocks if your application is complex and if it gets costly in terms of cloud costs, and if it gets problematic in arranging desired behaviors, for example, resiliency testing or some sophisticated setups. To achieve mocking, one of the open source tools to use that is Mockintosh tool, which we designed specifically for cloud native environments. So it's Docker friendly, it is lightweight, and it uses the knowledge accumulated over years in mocking area to provide the most crucial features for the main use cases. To begin with, we need to install Mockintosh, and you can do that in two different ways. Let's jump into demonstrational things. Mockintosh itself, its home is mockintosh.io, and you can read the docs here. You can quick start with installations. Everything I'm mentioning, you can read it there. And Mockintosh is written in Python language, but you don't care. Fairly, you don't care because you don't need to know Python to use it. It's all driven by configuration files. And the only need for Python is when you want to install it to use as Mockintosh command. Then you need Python on your machine and you need to install Mockintosh, which is easy. Let's say I have here the clean Ubuntu Linux, which can be Mac, which can be Windows. And I'm just issuing a simple command, pip install Mockintosh. And it will install all of the dependencies, and it will install the Mockintosh tool itself. And I will be able to use the Mockintosh tool from command line to start up the tool. Let's give it a second to continue installation. That's it. It's now operational. I can run it, Mockintosh help, and see the command line help of the tool. Good. The second alternative would be to run it as Docker container. And as Docker container, I can just have Docker on my machine and use the command like this. Docker and same help command. Oh, okay, this Docker container shouldn't be there. And it would fetch the container, the image if you don't have one. I already have downloaded one, and Mockintosh is able to function. In this demo, I will be using Mockintosh command line because Docker is slightly more noisy in terms of command line options, but everything I show can be used with Docker image with no problem. So don't think that you need to know Python or to install Python. You can use it as Docker, you can use it in Kubernetes, all of that. So let's start with first basic usage example. For the Mockintosh, you need a configuration file. So I have this empty file, and let's start writing our first configuration example. Mockintosh operates with services. So you need to specify at least one service, and it's good to specify a name for it. First example will be the name for it. The port is very important option. It's where we will access the mock. How will we connect to it? Let's say 8001. And endpoints. We need to specify the API endpoints to use. The first endpoint will be just on the root of it, and it will respond hello. I'm saving the file and I'm jumping into command line to run it. Mockintosh simple.yaml. It tells me the mock server is ready, and it gives me the link to open in my browser. And you can see that it replies hello to me. It's good. Now let's make it more complex. Let's say I want to use the external file, which I prepared upfront, this HTML file. So I want now to serve this HTML file. Let's actually add it another path, and it will be, let's say, HTML, and any page, anything that I will place there will be responded from an HTML file, webpage.html. Now I need to restart Mockintosh, which we will learn how to avoid that in a couple of minutes. So it still responds hello, but now when we do HTML page 1, it responds with this example. And if I refresh, you can see that the content actually changes. Why is that? It is because I have used in this web page special templating equations, which you can use. There's a lot of interesting functions, and in response templating, you can learn how to create those dynamic values. There's a lot of typical functions like random names, random dates, random numbers, strings, that you can make your mock to respond with some variety of data. And here you can see that page 1, page 2, whatever I put there, it will still respond because we used the templating inside our mock configuration. Let's quickly summarize how Mockintosh works inside. The principle of working is very simple. It receives the request according to the port and sometimes the hostname configurations, multi-service configuration. Then it searches for endpoint inside the list of endpoints, which will match the request. Then it locates the response, because we can have sometimes multiple response. I will demonstrate that. And it takes appropriate response and it renders it back according to templating functions to that functionality. This is it. This is how Mockintosh basically works. Receive the request, match it to endpoint, locate the response to respond with, and render that response back. And you can get pretty far with that because your response can differ. For example, here you can have multiple responses. One is hello, another is goodbye. And now if we'll restart the Mockintosh and we'll navigate to the homepage of the mock website, it will respond hello, goodbye. So you can imagine that you can get pretty complex behaviors like polling patterns with this. It can respond with error, error, and then success, or vice versa. Another interesting thing to do with Mockintosh is the multi-service. You can have another service named second, and it will have different port 8002 and endpoints, and we'll have path root of it, response, and let's say the response this time I will have status 403, and I will simulate the failure. So now you can see that we have two services, and I can access it from command line, let's say curl, and let's make it print. You can see now we have 403. There's also some signature to tell that it was actually served by Mockintosh. But you already see that it's quite problematic when I'm starting to experimenting and tuning this configuration file. I'll have to restart the Mockintosh process all the time. And it's not very convenient. And this is why Mockintosh has the UI to manage it. It's called management UI, and we can use, let's say, port 8000, and we start Mockintosh once with it. And then we can do different things through the management UI. Localhost port 8000, and we have the UI that shows us which endpoints do we have. It allows us to try it quickly. So we can try it here and get forbidden. We can try it here, and okay, it wants the page is any, and it responds with HTML. We can try the root and see how it responds with dynamically changing hello and goodbye here. So quick trying is one capability of it. Another thing is we can see the traffic log. We can see which requests were served by this mock. For example, when we query it with this request, we can see here all the request headers, all the response headers that we were using. We can request it here, and we can see the requests and responses. From the browser, we have much more request headers, and let's make it larger a bit. We can see that we were responding with goodbye and then hello, and the same mock signature to tell that it was actually a mock. Another capability of Mockintosh management UI, or control plane, how we call it, is the ability to see the statistics, how many requests were served. So you can see what was in short happening in the mock, how many different responses were served by it. And the most interesting thing is the ability to actually change the configuration of it live on the fly. So here we can have now hello 2 and goodbye 2, and we can apply the changes, no need to restart anything, and it will be hello 2 and goodbye 2. and we can change anything in our responses, configurations, and endpoints, and it will be dynamically applied, which you can now see with example of the full microservice setup, how it becomes really important when you are running it not like a local process, which is still great for local experimenting, but when it becomes a part of environment. And for that we will use this sock shop demo application, which is a nice piece to experiment with microservices. And I have downloaded the Docker Compose definition of this service, which consists from many services. You could be using Kubernetes for that, but it's slightly easier to demo with Docker Compose. So we have these services here, and we can bring it up as Docker Compose up. It will spin up for several minutes to bring up these containers with microservices. And if we will look at the diagram of services in this application, it starts with the browser accessing the edge router microservice, which then goes to front-end microservice. And from there you get to catalog, carts, orders, user, and maybe other services. So it's pretty sophisticated, yet simple enough microservice to operate with. And let's see if it was able to launch. Yes, it was. It's still in the process of starting, so we are not having it fully functioning. Let's give it a couple more minutes to come up. Right. So it's coming up. Let's wait a couple more minutes. All right, so here we go. No, not yet. Let me quickly see what's wrong there. The cart service is always lagging behind. Let's go to catalog. It's still in the process of starting. All right, so I will not wait for it to start fully because I want to actually go ahead and replace the microservice inside it, this one with the mock. It is the catalog service, which is used to serve the catalog of socks to the front end to display in the browser. By the way, here it is, it should be now. Yes, so we have it up. So we have a catalog of these socks and it's all functioning. But now I want to replace the catalog microservice and actually take control over it. And I want to show that I can experiment with it. What I will do is I will bring it down and I will take the definition of catalog microservice and I will duplicate it. I will duplicate it, and the old, I will just add suffix old to it. And I will change the host name of it into host name old. And with the copy of it, I will take prepared piece and I will inject some alternative configuration. Instead of original Docker image, I will use the Mockintosh Docker image. I will attach my current directory as config file and will change the config file to use Mockintosh vivsock YAML file, and I will tell it to use specific ports. Port 80 is the main port of the mock, and port 8000 will be used for management. What's inside Mockintosh vivsock.yaml? It's pretty simple. We're saying that we will use the management API, and we will use one service, but actually we will make it fall back to the real service. This is why we kept the catalog old here, because we want to fall back to it to learn the pieces of configuration by using management API. I could actually written here endpoints and specify some 1, 2, 3 path. If I have the configuration prepared for me somehow, but if I don't have a configuration, I can use this fallback feature. Let's make it start and Docker Compose up. We can see now that there is the catalog old and there is the catalog service, which is starting. And by the way, regarding getting the configurations somehow created for you, you can actually use this Up9 platform. As part of the platform, there is ability to download the mocks configuration if you have attached Up9 to your application. We will need to wait for it several minutes to start the app. We can try to query it now. Does it work? It should. It should work. Let's see. I'm refreshing this page and I can see that some requests are happening. What interests me is how catalog service gets queried. And you can see that the catalog, which is mock, says that it will forward request into catalog old. And now I can see the catalog old getting and serving this request. And then the Macintosh responds with it. This is why we're seeing transparent functioning of the website still. But if we will look now into Macintosh management API, you can see that the configuration, it has no endpoint still. But I can navigate now to unhandled requests pane, where I can find my requests that were happening in the format of Mockintosh configuration. And I can just copy it and just put it here into my endpoints. Apply. And now interesting thing will happen. If I will change the name from colorful to colorful123, and I will change it again to save. If I will refresh my page, you can see now I got the control over this API. Although it is deep inside here, my browser speaks to Edge Router. This is the service on the third tier of the application. But now I can experiment with that service without changing Edge Router, without configuring anything in front end, without restarting the whole application. I can now experiment. Let's say I'm a front-end developer and I want to understand how will it behave if anything will change. Let's imagine something. Let's imagine if there was a nasty tags inside my JSON. Will it still work fine or will it break it? Applying the change, refreshing, it will function well. So it doesn't suffer from HTML tags there. So I can do anything I want with that API. Let's say I have this catalog, and inside that catalog, I want to leave only, I don't know, or maybe I want to change this holy holy socks with different images of these socks. I will apply the changes and I will now navigate to home page of it. What's wrong with you? The cart service isn't happy. Oh, okay, let's get back to catalog. Okay, I know what happens. Actually, the template was too strict. So let's make template to be less strict. It's ID here, and let's make it not look at this. Apply, okay. Now we can see it. And you can see that instead of ugly holy socks, if you remember, it was embarrassing socks image. Now it's funny. And we just took it and copy pasted. So we have all the control of it. We will need to work more on covering these socks too in our mocks. So now, this all was the experimentation or setup manual. But what if I want to use the Mockintosh capabilities to actually do automated testing? And I don't want to do manual configuration of mocks. I want to use the auto test approach. What we will do is we will affect the same catalog service, but it actually, there's no line here, but there's actually an API call from cart service into catalog service when I'm adding the socks into cart. When I'm doing this, when I'm choosing the socks and I'm adding to cart, there is additional call made to catalog service, and we can actually track it from here. It would be funny to see it here. Let's take some socks and add to cart. And you can see how many requests were served by Mockintosh. So I want to program that into automatic test. And I have prepared the code for such a test in my preparation. So this is Python, but it could be Java, it could be any language. Why? Because I'm not using any Python specific features to access the Mockintosh. Instead, I'm using the API, the Mockintosh Management API, which is described here. There is an API to change the settings of mock, which, by the way, is used by this UI here. So it uses the same API. And I can have following behavior. I'm configuring the mock. This is the setup phase of my test. I'm configuring the mock service to respond with my desired responses. In this case, it will be the fake socks something 55.55. And I'm coding my behavior, which will be consisting from emptying the cart because I want to have a clear cart. Then I'll be adding an item to my cart. This is my valid API call to the cart service, which goes through edge router and front-end microservice, and it goes to the carts here. But the carts will talk to catalog, and I want catalog to respond in a special way, in my way. So after we have added the item into cart, we will validate its status. We're getting cart and we're making sure that we see the JSON. We could put assert on the price of an item inside the cart. So let's see how it works. I'm running the test and it worked. And you can see here that the printed text from here, it was my ID, and the unit price is 55.55, because this is what I have configured here in my mock. And I can change it to 5566, run it again, and see that the price has changed. I'm talking to cart and I'm working on cart's microservice, but I have isolated the dependency from catalog. This is positive scenario. What if I want to test how my cart service, this one, will work if the catalog is down? This is the negative scenario, and it's a sort of resiliency testing when the catalog will respond with some erroneous response. How do I do that? I'm doing that in a very simple way. I'm configuring Mockintosh with the config file, or a piece of config, to respond to catalog request with status 504. Let's say I'm simulating the outage of catalog service. And still, I will make sure my cart is empty, and I will try to put an item into cart. And I expect it to fail with 502. I'm running this test, and it passes because indeed my request has responded 502. But the interesting thing that I found when I was preparing for this demonstration, that the demo application actually crashes inside. So it actually exits because of unexpected failure. The cart's microservice and the frontend is unable to handle that. So it stops the microservice and quickly restarts it. But still we have the negative test working. I was able to find this problem in my test application by using simulated failure. And we should be able to see that simulated failure here. So this was the response from the mock. And the previous response to the very same request was successful because it was the positive test. This is how you use Mockintosh in automated test. This is just one way of using Mockintosh in automated test. I could use what is called tagged responses when I'm configuring multiple responses, but I'm choosing which one to respond with some API call to Mockintosh management API. There are many capabilities like that in the tool because we know that it's problematic to affect the services when you are deep into architecture of multiple layers of application inside Kubernetes, inside Docker Compose. So it's hard to restart the service every time you want to do something. So instead of restarting the service, you can just trigger the change in the mock behavior, and you don't need to have the databases. You don't need to have large-scale applications deployed. You can have it all as part of your single computer because Mockintosh is able to serve multiple services on multiple ports from the single computer. Let's see what we have else. Automated tests, language neutral, will work in any language because of using APIs and not programming languages. Auto-generated configs for mocks, we covered that. There is Up9 platform where we can take and export specifications for these services. I will not go there today because we're running out of time. I want to spend some time answering your questions. There is a plan we already have in Up9 blog. Let me show you that. Blog. We have some blog posts, and we have started writing the blog posts about Mockintosh, and there will be a blog post about getting started of it. So keep an eye on the blog because we'll be posting more interesting and deep guides on how to use mocks for front-end development, how to use mocks for Kafka and message bus technologies, how to do chaos engineering and resiliency testing, what are the capabilities of Mockintosh to help with that, and some more. we will do more webinars for sure. I'll be showing this style of webinars with practical examples. And thank you for watching. I will ask you to provide as much feedback as possible to this webinar to drive the further webinars that we do, that I will do with demonstrations. What you want to learn about mocking, which use cases do you want to see? So with this, my presentation part ends, and let's spend some time answering the questions. Noga, do we have some questions?
Yes, we do.
Great.
Thanks, Andrey. It's really interesting. So our first question is from Artem, and he's asking if it's possible to dump or save the configuration YAML that he created on the fly via UI.
There is an API call you can issue to get the resulting configuration. It's available here. I agree that we need the feature to actually store this configuration as files somewhere. It's actually tricky question, because if your configuration is, if your Mockintosh is running deep inside cluster somewhere in Kubernetes, it will be problematic for you to access the file. So it's actually more viable to get and copy it through API or through management UI. But this feature, it's not there yet. It will be there because we internally we already found this as a gap. So not today, but in future versions, it will be there.
Amazing. So we have a question from Alexei, and he's asking if Macintosh can be connected to a database.
No, Mockintosh cannot be connected to database, because this is exactly the point why you use mock. You want to avoid connection to databases because of the heavy setups. But there is one feature which will resemble a database in Mockintosh. There is dataset feature when you configure. Let me find that data set. Yes, you can have data sets for the responses, so it will be served from the response. Yeah, the fake data. So you can have a data set inside CSV file, for example, or data set JSON. It's not CSV, but JSON, or maybe it's CSV also. But you can use that to simulate multiple varying responses. I would say from my experience, it's usually not needed in most of the cases, because you are going with templating and dynamic functions like random name, random something, because the point of mock is to be simple. If you're starting to attach a database, if you're starting to write some logic there, then it's probably wrong. You're not supposed to do complex things or complicated things. But again, with data sets, you can dump the data from database and ship it with endpoint, and it will serve. And by the way, if it's that Alexei Semidotsky who I worked with in the past, cheers, man. It's nice to see you on the webinar, because I worked with one Alexei in the past.
It is, actually. And he also added a clarification that he meant the test database with fake data for tests.
So the data set is the fake database.
And he had one more question. What's the Python web framework used under the hood in Macintosh?
It's Tornado. It's asynchronous Tornado used inside, but you don't care what's inside, because you're not supposed to be Python developer to use Mockintosh. You are free to use any technology with Mockintosh.
Great. And he says he's glad to see you too. So we have a lot more questions. So I'll do one question from each participant, and then if we have more time, we'll go back. So Arun is asking which data protocols are supported by Macintosh.
Let me see the question. Maybe I'll see something. Which data? Okay, I'm not sure I understand the question about data protocols. For today, we support HTTP REST calls, which are most typical API calls, but In work in progress, which will be released very soon, is the Kafka support. And shortly after Kafka, there will be support for RabbitMQ and then for Redis to be used as message bus systems. How to simulate response time in Mockintosh. There is the performance profiles. So you can configure the performance profile, which would look like, well, performance. Do I have it here? No, I don't. So we can use performance profile and we can simulate response codes, delays as part of the profiles. It will be like this. Let's quickly test if it will work. I don't want to touch that thing. Terminal and Mockintosh simple YAML. No port conflicts. Okay, so we have 8,000. Oh, no. We should have specified performance profile and profile 1. I hope I didn't mess up the config. No, I didn't. So now when we are requesting anything from here, which will be curl localhost 8001, you see it now responds with constant delay of 1.5 seconds. And we can simulate different failures, response codes. This is mainly for resiliency testing profiles. How to share Macintosh mock service URL to external users. For that, you would need to deploy it in some environment and route the traffic. It always happens with mocks. Mocking and serving the mock is one thing, and routing and plumbing the connections around it is another thing. So there is a blog post which is supposed to be published today or tomorrow, where I'm at the end of that getting started blog post of Mockintosh, I'm describing in details how you route, how you solve these problems, how you expose the service or using host overrides, for example. So keep track of the blog post, you will get some information on that. How to use Mockintosh for performance testing. To use Mockintosh for performance testing, you would need to make sure you are scaling it up. For example, you're putting it into Kubernetes with some auto scaling, and then just use it because it's pretty simple. It doesn't eat much resources and it scales well. It will make no sense to track the traffic logs or things that do additional things, and do less templating. When you use templating, response templating like this, it affects your CPU. So usually you do it with less templating. And in general, you can just place the same way I placed it here as replacement of catalog. I would place it here, but I would assign it more resources and I would make it to scale with some sort of auto scalers. I saw the question of, is it possible to mock a third-party API? Definitely, you can do that. So if you have configuration ready for the mock, or you can use the same trick that I used, if you remember, I used the fallback option. So by using this option, you can quickly learn which API calls you actually need to cover from the mock. Let's say we see the new requests that we should have covered, and you can mock any external dependency, even the one that you don't own. But in this example, in this case, also, I will tell you that there will be a blog post where I'm telling how to mock something that the traffic will actually go to, instead of third party, in, let's say, GitHub API or Stripe API. Instead of Stripe, it will go to Mockintosh because you will replace the host names, or you will route the traffic through service mesh if you use one, something like that. I hope this answers the question. Do we have anything?
Yes.
Okay. Can I mock a service communicating using a message broker as ActiveMQ? Not today, but this is something that we're actively developing, and it will be quite soon available. We will announce that, we will release that. I think we will have a webinar on that, because it's worth demonstrating how we do the Kafka or message bus mocking. Javier, feel free to ask your question. I see your hand. Okay, any more questions?
Yeah. If there are any more questions, feel free to ask them now. We have a new one. Do you see? Videos on YouTube for somewhere on how this product works. The webinar will be available, and creating videos is a good idea. Let's do it, Andrey.
Yes. Let's do that. If I'll have good time, and why not? We should do that because it's interesting technology.
And Javier also wanted to ask about the videos. Okay.
All right.
So we have a lot of the audience is interested in videos. Great. If you have any more questions, please ask them now. If not, we're going to wrap it up. Okay, I think that's it. Oh, we have one last question. What's the difference between Macintosh and Macun.com? Andrey, are you familiar with it?
Yeah, I'm familiar with Macun. One of the differences is that Macun has less focus on command line and more focus on UI-based building of mocks, which I believe is different from what we do in Mockintosh, because instead of focusing on building the mock here, we are relying on config files, on the generated config files, because I believe nobody wants to spend a lot of time in configuring the mock through UI, and fairly the syntax of Mockintosh configuration file is not that complex, so I don't think you need much of UI to build it. Instead, I'm focusing on the capabilities like traffic log, like the ability to quickly experiment with your APIs, and the ability to quickly get the configuration from the real service. And for example, to get the configuration from Up9 if you use the Up9 tapping. And this is the difference in focus. In terms of capabilities of the end mocking, we will probably be more or less the same until the moment when we'll release the Kafka mock agents or RabbitMQ mock agents, when we'll be addressing completely new chunk of the problem with mocking Kafka-related services, because we are setting for ourselves the goal to be cloud-native mocking tool. And cloud-native means these fancy Kafka message bus asynchronous communication patterns, which make us slightly different from the tools from previous generation, when only HTTP APIs and REST APIs were the main technology that everyone used. This is why the technologies just followed. And now we have Kafka, and Mockintosh follows that trend to add features on top of that.
Great. And we do have one last question about how do we get hands-on with this tool with some support from you. I think that's where the community comes in, right, Andrey?
Yeah, we have the web page where you can get the basic documentation for it. Up9 will be the source of blog posts, resources, and webinars about that tool. There is the GitHub page where you can look at the source code, see how development is happening, see who's actually doing most of the programming for the Mockintosh project, and it's not me. And you can ask your questions, raise issues, and offer pull requests if you want, and ask whatever. And I believe there is the contact us. If you don't know where to go, just go there and ask your question there, and we'll be happy. It will be routed to me if needed, and we'll answer that question.
Wonderful. Okay, we do have to wrap it up now. So thank you everyone for joining. Have a wonderful rest of your day. Andrey, thank you so much.
Thanks everyone.
Amazing. And stay tuned. You'll get the webinar in your inbox, and stay tuned on our blog for more blog posts and more webinars. And follow us on LinkedIn to also see when we'll be advertising new things. That's it.
Okay,
Thanks.
bye.
Bye-bye.